Our last conic section that we're going to look at are hyperbolas. Again, I wanted you to see why is it called a conic section, because if you take what we call a double cone, we have two cones put together, and slice it with the plane, you get two branches called a hyperbola. This is actually showing you a solid cone, slicing it, and again that cross-sectional area would be a hyperbola. Also what this shows you is that the sides of the cone, those are going to become our asymptotes in our figure because this hyperbola approaches that side asymptotically. Let's look at the definition. The definition is the set of all points, the difference of whose distances from two fixed points, or the foci, is a constant. You may recall that the definition of the ellipse was the exact same thing, except we had the word sum there. These two pictures, you can see that we have hyperbolas where we have branches side to side or branches up and down vertically. You can see the asymptotes, and then this green rectangle we'll talk about how that's going to help us graph it. But before we go further, I'd like to show you the demonstration of how you can arrive at these hyperbolas through the definition. We've seen this before on the ellipse, so by the definition, the sum of the difference of the distances between from the point to each focus, point to focus, if you subtract those, that's going to be a constant. And in this case, it's going to be 2. So as I move that point around, you can see that again the difference stays 2. Then of course we could switch it over to the other branch. You can see the same thing. So as we plot out those points, the difference between the distances gives you those two branches of the hyperbola. Unlike the ellipse, we do not have a major and a minor axis. We have a transverse axis and a conjugate axis. The transverse axis connects the two vertices. This would be a vertex, that would be a vertex. There's a vertex, and there's a vertex. So in this case, this would be the transverse axis, and here this would be the transverse axis. It's not a matter of big and small. In this case, it's going to be a matter of positive and negative. So that conjugate axis is just perpendicular to the transverse axis. These two black dots are going to be our two foci. And look, they're located on that transverse axis. And then of course we have two asymptotes. So let's fill out these blanks. The foci are always located on the transverse axis. Not the biggest, not the smallest, but the transverse axis. What is the distance from the center to each focus? What was it on the ellipse? What letter did we apply? We used the letter C, and we're going to stay with that. What is the distance from the center to each vertex? Again, what did we use on the ellipse? And we're going to stay with that, and that was the letter A. And then what are the endpoints of the transverse axis? Those are called vertices. So again, here to here would be A. We have C. Believe it or not, the width of the axis is of course 2B. Sounds very similar to the ellipse. We're going to use those same letters so we won't be confused. We have equations, one where we have a transverse axis parallel to the x-axis, meaning the branches run horizontally. We have an H and K, which is the center, so that stays the same. Look at this formula. It looks exactly the same as the ellipse, except now we have minus signs instead of plus signs. So subtraction is not commutative. Order does matter. So this is the positive value, this is the negative value. Whatever is the positive one, that's going to be your transverse axis, or what's parallel to it. So if x is positive, we're going to have a transverse axis that's parallel to the x-axis. Over here, this is the positive quantity. This is the negative because of that minus sign. The y is positive, so our transverse axis is parallel to the y-axis. I want to again emphasize that we have that h and k. H always goes with x, k always goes with y. So over here, that may seem a little backwards, but you've got to pair them up. Again, think alphabetically. We also have asymptotes, so that's different than the ellipse. The ellipse didn't have any asymptotes. And there's lots of different ways different books present this. I like to use one formula to go back to the idea that a line has a slope, and that slope has been defined as rise over run, or the y direction over the x direction. That y minus k and x minus h just shifts the line from the origin to the center of hk. Then we have that relationship between a, b, and c. That is the Pythagorean theorem. It looks just like the ellipse, except that has a plus. So where this is plus, those are minuses. And on the ellipse, just backwards. So again, you've got to keep that all straight. Let's work through our first example. We're going to be asked to find the same things we did on the ellipse, in addition to finding the equation of the asymptotes that the hyperbola has that the ellipse does not. So I think the first thing we need to do is find the center. So remember, the center is hk, alphabetical. X comes before y. So that means I need to look at those two values and put them in the correct order. And just like the ellipse, we want to take the opposite. So I want positive 2, negative 3. I want x before the y, h before the k. So let's graph that, or plot that point, 2, negative 3. Then, how are we going to graph it? Just like the ellipse, we're going to take the square root of those numbers, and since this came underneath y, we're going to go up and down from the center to, we're going to take the square root of 9, and that became underneath x, so I want to go side to side from the center. And then we're going to make that box, connecting those dots, making a rectangle. That's not the graph, that's just going to help us graph it. Then we're going to graph the asymptotes. The asymptotes go through the corners of the rectangle and the center. That's one asymptote. And the second asymptote, again, want to go through the corners and the center, but you want to go beyond the rectangle. Still haven't graphed the hyperbola. Keep going. Let's talk about the vertices. The vertices are located on what's called the transverse axis. Not the major, not the minor, the transverse axis, which we're going to get from the positive term. So if this is in standard form, whatever variable comes first, that your axis is going to run parallel. So this is the transverse axis is going to be parallel to your y-axis. So it's going to up and down. What does that tell me? It tells me my vertices are those 2 points. Now I can graph it. So using those 2 points, the vertices, and my asymptotes as guidelines, I have 2 arches that run along kind of the box, or I call the rectangle, and our asymptotes. That's the graph. So let's go ahead and write down the coordinates for the vertices. I'm going to have 2, negative 3, which is my center, and then I went up and down 2 for my vertices. You can also just read them from the graph. So we would have 2, negative 5 and 2, negative 1. Here and here, those are my vertices. Now I want to find my foci. Well, in order to find my foci, I have to find C. So I have to use this relationship. Remember, for a hyperbola that's minus, this is going to be plus. And our a and b squares are our denominators. Notice that a is actually smaller than b. That's okay. This is not an ellipse. It's not about bigger and smaller. It's about that positive and negative. So c is plus or minus the square root of 13. So my foci, again, starting from my center, and because it's located on that transverse axis, I'm going to add and subtract from the y value. I can't simplify those. So let's see, I found the center, the foci, the vertices, I've graphed, so the last thing I have to do are the asymptotes. Let's look at that formula. That was y minus k, not squared because it's a line, plus or minus rise over run times x minus h. Well, y plus 3 equals plus or minus, I'm going to leave that blank for a minute, x minus 2. Now what's this rise over run? From the center to a corner, rise over run. How far did I rise? How far did I run? Well, I went from the center to the vertex, that's 2, and the vertex to the end point of that box, that's 3. And the reasons why it's plus or minus is because I can go up and left and get that second asymptote. And you may leave it, and I would prefer if you just left it in that form. Now we're going to look at the second example. Notice it is not in standard form. We're going to have to do that completing the square. Always can use more practice. So let's group our x terms and our y terms and put everything else on the other side of the equal sign. In order to complete the square, remember the coefficients of our squared terms has to be positive 1. So I need to do some factoring. So I'm going to factor out the 9. I'm going to factor out negative 25. Be careful. If I divide or factor out a negative 25 out of negative 50, that's going to be positive 2. Now I can take half of this, square it. Be careful, I've not just added 9, but I have to multiply by that 9 on the outside, so I've added 81. Here I'm going to take half of 2, square it, but I have to multiply because it's inside those parentheses, so I've really added a negative 25. Be careful with the signs. Now just collect like terms and you should get 225. Looking better. The last thing I have to do is get this to be 1, so I'm going to divide everything by 225 and reduce those fractions. And guess what? 9 goes into 225 25 times. 25 goes into there 9 times, and we have 1. So there's my standard form. From there I should be able to get everything. All right, so what's my center? Remember h, k, so I have positive 3, negative 1. The square root of 25 is plus or minus 5, and it's underneath x, so I'm going to go out 5 from the center. Square root of 9, and again that's underneath y, so I'm going to go up 3 and down 3. I'm not in ellipse land, so I need to draw my rectangle. Then I need to graph my asymptotes. Remember, I want to go through the center and the corners of the rectangle and beyond. Those are my asymptotes. Now, where are my vertices? Let's come back and look at here. Which one's your transverse axis? Which one was positive, which means didn't have the negative in front of it? It was the x, so my transverse axis is horizontal, which means those are my two vertices. So my two vertices are 3 plus or minus 5, negative 1. I'm adding this value to the x, and again you can just read them off the graph. So that's 8, negative 1, and negative 2, negative 1. Now I need to find my foci. So my foci is c squared equals a squared plus b squared. So those are just your denominators. So I have my center, and I plus or minus the square root of 34, and the y-coordinate stays the same. And the last thing I need to do is find the asymptotes. So I start out with y equals mx plus b. So y starts first, so I have y plus 1 equals plus or minus. Then I have the x minus 3, and right here I want to do rise over run. Rise over run. So how far did I go up from the center? 3. How far did I go left to right? 5. And again it's plus or minus because I have two asymptotes. Since our transverse axis is in the x direction and those are our vertices, let's go ahead and finish up our graph. I'm going to have those two branches going side to side, because again that would be the transverse axis.